Welcome to video number 6. In this video, we're going to take a look at how we can directly respond to a user's finger making contact with the screen while our application is open. So previously, the only way we've dealt with user interaction is by using objects that are built to already handle the user interaction for us. So for example, we've used buttons and table views and sliders, and those really do all the work. They abstract out a lot of the groundwork and principles that go into handling user interaction with those type of control objects. In this video, we're going to actually track where the user's finger makes contact with the screen and continuously track it so long as they keep their finger down on the screen and move it around. Specifically, we're going to make an app that launches with an image in the center of the screen, and if the user taps their finger on the image and drags it around, the image will follow their finger, or in our case, since we'll be using the simulator, it'll follow the mouse. So let's get started by opening Xcode, and let's create a new project. Single view application still works. Click Next. I'm going to title my project Touch Tests. And as always, create it on the desktop. Right now on my desktop, I already have an image that I'm going to use for placing in the center of the screen. We're going to import this image into Xcode and then use something called the UI ImageView to display the image inside of our view controller's view. So let's go back to Xcode. And let's discuss some things about how views are laid out. So let's go to main.storyboard. So anytime you have a view or a subclass of a UI view object, it has something called a frame. And that frame determines where that view is located on the screen or in its superview and how wide and how tall it is. So with the view selected, open the size inspector in the utilities panel. And here you can see 4 properties that describe the view's position on the screen and how wide and how tall it is. On the iPhone, by default, the top left corner of the screen, if you imagine the screen as a grid, is the origin or the point 0, 0. As you travel down the screen, the Y values increase positively, and as you travel to the right on the screen, the X values increase positively. Academically, as you've probably learned in middle school, high school, and even college, if you start an XY coordinate plane at the origin 0, 0, and you go down, the Y values increase negatively, and as you go to the right, the X values increase positively. So the only mental adjustment you have to make is just to remember that when you're dealing with an iPhone screen or a view on an iPhone screen, even though going to the right still increases the X value positively, going down actually increases the Y values positively. So if the top left corner of the screen is 0, 0, the bottom left corner of the screen is the point 0, 568, which is the full height of an iPhone 5, 5S, or 5C screen. So anyway, back to our size inspector. You can see the X value of where the view starts, the Y value of where the view starts, which is again the origin or the top left corner of the screen, and then the width of the view, which is 320, or the full width of an iPhone screen, and then the height of the screen, or 568, which is the full height of an iPhone 5 screen. Once we've created an image view and placed our image in the center of the screen, we're going to manipulate the X and Y coordinates of that view to allow the user to drag the image around on the screen to any place they like. Fortunately, as I'm sure you've become used to, Apple has implemented a very, very easy-to-use system that allow us to include a feature like tracking the user's finger motion across the screen. At this point, you've hopefully become accustomed to this idea of a view controller maintaining and manipulating a view, and when something happens to that view, the view controller is notified so you can programmatically respond to any event that occurs in your view that you need to. Fortunately, with touch response, this is no different. So if the user's finger makes contact with the view controller's view, the view controller is notified by means of a few method calls, and of course these methods follow a very specific format, and by implementing these methods, you can respond to the user's finger tapping, dragging, and releasing from the screen any way you like. iOS is designed so that when a user interacts with the screen, the root view of whatever application is opened is notified first, and then any subviews that exist inside of that root view that also consume that same place on the screen that the user tapped their finger will be notified one at a time in a sort of domino chain until there are no more subviews to notify any further. In other words, starting with the root view, every subview that exists at the point the user tapped the screen will be notified one at a time until the final descendant is notified and can respond how it likes. So first, the UI window which is the root view of our application, will be notified. And then next, the view controller will be notified, and then any subviews inside of our view controller's view will be notified. There's one criterion that a view has to meet to respond to a user's touch, and that's to have its user interaction enable property set to yes. So if you select the view and you open the attributes inspector, you can see labeled interaction, there's a check mark next to something called user interaction enabled. Only views that have this property set to yes will be notified if the user makes contact on the screen at the place that view exists. So if we uncheck this and the user touches our view, we will never be notified that the user did in fact touch the screen. So this has to be set to yes. And again, any other views that you want to respond to user touch also must have this set to yes. You can see there's a second option here that says multiple touch and it's left unchecked. If this is checked, your view will handle multiple fingers tapping and moving on the screen at the same time. For simplicity's sake, we're just going to deal with one touch at a time. We're going to leave multiple touch disabled. So later on, when we add our image to the center of our view, we're going to have to make sure that this is enabled so that if the user does in fact touch the image view, we can prepare that image view to be dragged around should they drag their finger on the screen away from where the image originally was. Let's begin by implementing the first of the three methods that allow us to respond to a user's touch. Go to viewController.m, and we're going to implement a method called touchesBegan_with_event. If a user's finger makes contact with our view, the view controller will be automatically messaged in this form so that inside of this method's implementation we can respond to that touch. The first argument is a set containing UI touch objects that represent any one individual touch on the screen. And the second argument, which is a UI event object, just describes some properties of that interaction. For example, whether it was a user's finger touching the screen or the user shaking a device. It also includes a timestamp for when that interaction occurred. So all we need to be concerned with is this set here. And the first thing we're going to do is we're going to pull out the UI touch object that represents that touch. So since we left multiple touches disabled, this set will only contain one touch object at a time, which will be the first finger that touches the screen. And as long as the user keeps that first finger on the screen, any other fingers will be ignored until they lift the original finger off the screen. So again, this set will only contain one object at any time because we have multiple touches disabled. So a UI touch object is an object that contains information that we can use to determine exactly at what point, what XY coordinate on the screen the user's finger made contact inside of our view. So to begin, let's log to our console the point that the user's finger contacted the screen. So first, we have to grab a point or a CG point struct that contains an X value and a Y value for the location in the XY plane on the screen the user's finger made contact. We'll call it point, and we retrieve that point like this. So we call to the touch object and we send it a message, location and view, and then we pass in the view in which we want to figure out where the user's finger made contact with the screen. So we want to know where inside of our view controller's view the user's finger touched the screen, so we're going to pass in self.view, which is a reference to our view controller's view. So now, after this line, our point struct will contain a float X value and a float Y value for the exact coordinates of where the user's finger made contact with the screen. So now we can log this to the console like so. We use nslog, which logs an NSString object, and there's a nice little handy function that comes with the iOS SDK called NSString_from_CG_point, and it's a function that takes one argument, a CG point struct, and returns an NSString that represents the data contained in that point. In other words, it's a string that has an X and a Y value separated by a comma, and then we can log that string to the console. So let's save and run our application. And you can see, if we click anywhere in our view, to the console are logged an X and a Y value for where we touch the screen. So you can see if we touch far left and up, the values are small. If we touch down and to the right, the values are large. As of right now, we're using the 3.5-inch simulator, so you can see that the farthest point is 320, 480. So let's quit and run again with the 4-inch display. And now, the furthest point is 320, 568. Okay, so now, let's place an image in the center of our view and make it so that the user can drag the image around anywhere they like. So first, we have to add our image to our Xcode projects project folder. So we can simply drag the image from our Finder window. I like to check copy item into destinations group folder so that instead of keeping a reference to the original image on the desktop, Xcode's going to create a copy of that image and place it inside of its project folder. That way you don't have to worry about if the original item was deleted or moved. Click Finish. I place it in the supporting files subgroup since it's not a class file but an image file. And now you can see listed is me.png, and this is the image we're going to place on screen. Now let's go to main.storyboard, and in the object library, scroll down and look for an image view, represented by this icon. We can drag it onto the screen, and first let's figure out the height and width of our image. So we can do that by right-clicking and choosing Get Info from the Finder contextual menu. And you can see under More Info, dimensions 78 by 75. So now let's go back to Xcode and using the size inspector, set the width to 78 and the height to 75. Let's place it in the center of our view. And now using the attributes inspector, you can change the image. And here will be listed all the images you've imported to your project. And so, with a few easy steps, we have this image placed on our view. You can see if we select the view, the image view, with the attributes inspector still open, you can see that user interaction enabled is unchecked. So by default, an image view does not respond to user touches. If we want to allow the user to tap the image and drag it around the screen, we're going to have to enable user interaction. So check this off, and now our image view will in fact respond to a user's touch. Next, we have to add an IB outlet so that we can reference the image view from our code file. So IB outlet, UI image view, we'll just call it image view, save, go back to main.storyboard, and right click and drag from the view controller item in the scenes menu and connect it to the image view outlet. And now we can write our code. The first thing we need to do is determine if the user's finger made contact with the image view. This method, touchesBegan with event, in this context will be called so long as the user's finger makes contact anywhere on our view. We only want to respond if the user's finger taps on the image view inside of our view. So we're going to need an if statement to figure that out. Fortunately, there's a great method that Apple has written for us called hitTestWithEvent, which allows us to determine any subviews that exist inside of our view at the point that the user's finger made contact with the screen. So let's add a Boolean value, and we'll call it last touch was on image view. Let's set it by default to no in our viewDidLoad method. And now let's write an if statement. If self.view hit test with event, we can pass in the event object that's passed in here, because it's the same event, equals image view, then last touch was on image equals yes, else last touch was on image view equals no. So we message the view and we call the hitTestWithEvent method. We pass in a CG point, the point we grabbed here, and the view will check at that point and see if there are any subviews at that point contained inside of it. If there are, it'll return a reference to that subview. So, in other words, if the image view is located at this point, this method will return that image view. And this if statement will test true. So now we have a Boolean value that stores if the last touch that the user's finger made on the screen was at the point that the image view exists. Now we can implement a second method called touchesMoved with event, and this method will be called repeatedly as the user's finger moves across the screen. That method looks like this. So the first thing we want to do is, if last touch was on image view is equal to no, we're just going to return. We're immediately not going to execute any code, because if the user didn't touch the image view, intuitively it doesn't make sense for the image view to move if they move their finger around the screen. If we didn't check to see if the user's finger is on the image view, and then they started moving their finger and the image view moved with it, the image view would be moving, but it wouldn't be at the point that their finger was. So it would be very confusing to the user. So again, only if the user's finger starts inside of the image view are we going to allow the image view to move with their finger. At this point, we need two variables to store the last point on the screen that the user's finger made contact with. That way we can get a difference with the new point, or the new coordinates of their finger, and move our image view an appropriate number of units across the XY plane. So we need to add a float which we'll call last x, and another one which we'll call last y. And when the touchesBegin method is called, the initial point that their finger contacted the screen, we can pull directly from the CG point we get here. So last x equals point x, and last y equals point.y. So again, a CG point is a struct which contains two variables, an x and a y, and obviously x stores the x coordinate and y stores the y coordinate. Now we can move the image around to match the user's finger movements. So first, just like in the last method, we have to grab the touch object that stores information on where the user moved their finger to, or the new point on the screen that their finger is located. And we have to grab that point the same way we did in the previous method. Okay, so now we have the new point for where their finger is located. And now we can use some simple subtraction operations to determine the difference between where the user's finger last was and where it is now, and then we can move our image view that number of units left or right and up or down. Here we're going to use something called a CGRect. A CGRect is a struct which contains two more structs, one called CGPoint and one called CGSize, and the first one, CGPoint, contains the origin of that view, and the second one, CGSize, contains the width and height of that view. So if we go back to main.storyboard, and we click on our view, and we go back to the size inspector, these four variables here are stored inside of a CGRect. In other words, a CGRect is a struct that contains information for a view's frame. So let's go back to viewcontrol.m. And the first thing we're going to do is grab our image view's current frame. So CGRect, we'll call it frame, equals ImageView.frame. So now we have a struct that tells us where our image view currently is. Now we're going to adjust the frame's x and y values to match the user's finger movements. So we can do frame.origin.x plus equals point.x minus last x, and frame.origin.y plus equals point.y minus last y. So what we've done here is we've updated our image view's x and y coordinates such that the x coordinate is the difference between the current x value of the user's finger and the last x value of the user's finger, the last time they either touch the screen or move their finger, and we do the same for the y value. We get a difference for where the user's finger last was and where it is now. This way, it doesn't matter where on the screen the image view is, all we really care about is the difference. So, in other words, if the user moves their finger 1 unit to the right and 1 unit down, we're simply going to add 1 to the x and y values of the image view's current frame. If the user moves their finger left 1 unit and up 1 unit, we're going to add -1 to our image view's x and y coordinates, and it will move 1 to the left and 1 up. So if we take some example numbers, let's say that the user's last contact with the screen was at the x coordinate 3. Then they move their finger 1 unit to the left, so the new x coordinate is 2. Here, that would mean that point.x, which is the current x coordinate of the user's finger, is 2, and the last x coordinate was 3. So the math would come out to 2 minus 3, or -1, which would decrement the image view's X coordinate value by 1, thus moving it to the left. And the same thing for the Y coordinate. The next thing we have to do is give the image view this updated frame with the new XY coordinates. And we can simply do that like this. ImageView.frame equals frame. Believe it or not, if you take a view's frame, change the frame, and then give the view back that new frame, it'll automatically move or resize to match that new frame. So simply by changing a view's frame property to a new frame, the UI updates automatically occur. The last thing we have to do is update our last X and last Y values to match the new values or the new coordinate on the screen that the user's finger is. So last X equals point.x and last Y equals point.y. This way, the next time the touch is moved with event method is called, the new difference calculated will still be a relative difference. So now let's run our application and see if it works. So let's start by tapping on the image view and holding with our mouse or trackpad, whichever you're using. And if we drag around, you can see the image view follows. But if we start outside of the image view and drag, it doesn't follow because our hit test fails. The last thing we want to do is set some boundaries so the user can't drag the image view off of the screen. So let's quit the application, and here we'll add 4 if statements. One for a minimum x and a maximum x, and one for a minimum y and a maximum y. So if frame.origin.x is less than 0, frame.origin.x equals 0. If frame.origin.x is greater than, let's say, 300, frame.origin.x equals 300. And frame.origin.y is less than, let's say, 20. To account for the status bar, we'll cap it at 20. And for a maximum value for the y coordinate, if it's greater than, let's say, 530, frame.origin.y equals 530. Let's run the app again. And you can see we can't go any higher up than where the status bar starts. Can't go any further left than the left side of the screen. We can't go any further right than this. We could change the value since this is a little confusing, but it still is a boundary. And we can't go any further down than right there. So you can see with very little code and some very basic mathematical operations, we've implemented the awesome functionality that allows a user to drag something around on the screen. And nowadays there are tens of thousands, maybe even hundreds of thousands of apps that have some kind of feature that allows the user to drag something around on the screen. Usually you see this in games. And it's this kind of interaction that makes iOS devices so elegant and intuitive to any consumer. These kind of interactions just feel like the most obvious way to interact with an iPhone or iPad screen. Anyhow, that concludes video number 6. Head on over to video number 7 to start learning about view animations.